Assalamu alaikum. This video is for LS2 and 3 computers. So we did example number 1 on page 29. This is a logic circuit. Here we have to solve it and we have to make the truth table for it. So here you can see as it is divided in different parts, part 1, part 2 and part 3. So we try to solve it like this here. So this is part 1, in which you can see there are two logic circuits here. A, B and C are the inputs. P and Q however are the intermediate values which we have written by ourselves. So we can find the output of the first stage independently, and then we will treat these values of the output which we have found in part 1 will be the values for input of the second part. So P and Q will be the input for this stage and for this logic gate as well. So R will be the output here again. So for part 3, R would be the input for this logic gate here, R, and as you can see this is being joined to gate C here at the input. So R and C will be the input for this gate and X will be the final output. So here now right now we are solving part 1 here. So A, B and C and P and Q are the outputs. So as you can see, first gate is the AND gate and the second gate is the NOR gate here. So first of all we have to make the input values here. You have to make the input values. These are the input values only, and as you can see P and Q are the output values, so these are the output values. So first of all, for AND gate there are only input A and B, so we will focus on only A and B. The logic of AND gate is when A and B both are 1, the output will be 1. So as you can see, A and B both are 0, so output will be 0, again 0, output will be 0, and so on as we solve them. As you can see, only in the last one the output, both of them have 1. A and B are 1 and A and B are 1 here as well. So output is 1 and 1 here. So for P it is solved. Now for Q, this is the NOR gate. NOR gate has a logic that neither A nor input B should be 1. So none of them should be 1. It means both of them should be 0. So B and C are the logic gates, are the input values for this logic gate, and Q is the output. So for Q, we will only look for C here. You can see both of them are 0 here, so output is 1. Here one of them is 1, C is 1, so output is 0, and so on. Only again here both of them are 0, so output is 1. So this is how we got the value of P and Q. So first stage is solved. Now we are moving on to second stage here. As you can see, second stage has only one logic circuit. You can see it is a simple OR gate here. P and Q are the input values. Previously P and Q were the output values. P and Q were the output values here, but for the next gate they are for the input of the next stage. So P and Q are the input values for this OR gate, and R is the output value. So P and Q, we don't have to make the new values because P and Q are already present here. So we will simply use these values as they are for the next stage. So P and Q are here, and then R is the output here. So how did we get the value of R here? Again, P and Q are the input values, and this is the OR gate. The logic of OR gate is simple. Both either A or B, in this case P and Q, should be 1. So either P should be 1 or Q should be 1. So as you can see in the first stage, one of them is 1, Q is 1, so output is 1, and all of them are 0. Again here one of them is 1, the output is 1, and at the end one of them is 1, so output is 1. So we have R here as well. In the last one you can see this is an exclusive OR, or we also call it XOR gate or XOR gate. So you can see R is the input here, and C was the C is also an input. So you can see R value is coming here and C is joined here. So R and C are the input values, and X is the final output value. So R we have copied as it is from the top, as it will be the input value, and C again we copied the values of C from the previous truth table. Here we have the value of C, we copied the value of C here, and the output X is output when exclusive gate gives the output 1 when the input values are exclusive. It means the value should not be same. The value should not be 0 0, and the value should not be 1 and 1. They should be 0. They should be different, either 1 0 or 0 1. So you can see in the first gate one of them is 1 and the second is 0, so output will be 1. In the second one, this one is 0, this one is 1, so output will be 1. You can see in this one both of them are same values, so same values always give out the output 0. So this is 0 here. Again one of them is 1, here this one is 1, this one is 1, this one is 1, so output will be 1 in all of them. However, in the last one both of them are same values, so output is 0. So this is how we got the last value, which was X, and at the end we have to write all the values from the starting A, B, and C, then the intermediate values P, Q, and R, which we added by ourselves, and then the the final output, which was X. So write all the values together. This will be our final truth table. So this is how we solve the given logic circuit we can show all the output by showing all the values through this truth table, and truth table can show all the values, and you can trace out all the given values for the given output values at any given instant. So at stage 5, stage 6, you can see all the values there are present in the truth table. Jazakallah.